Assalamu alaikum class. In today's lecture we will cover how to implement queue using arrays. We already know that for queue implementation we need two ends, one for insertion and another for deletion, front and rear. We know that insertion will be done at rear and deletion will be done from front. So we need to decide in case of array which end will be our front and which end will be our rear. So if we use an array to hold queue elements, we cannot insert or remove at the front or the start of the array because this is expensive. Why? We may have to shift up all the element to the left side. At the time of insertion, we need to shift all the element to the right, and at the time of deletion, we need to shift all the element to the left. For the stack, we have implemented stack using array. We only need one end, but for queue, we need both ends. So if we're going to use front as the start of the array, this will be expensive. If we're going to use rear at the start of the array, this will be expensive. So what we're going to do, we're going to learn about a new topic, that is wraparound or circular queue using array. To get around this, we will not shift upon removal of an element. On this slide, a queue implementation using array is shown, and this is an array of size 8 from 0 to 7, and front is 0, rear is 3. Notice that front and rear will be indexes, not pointer, because we are implementing queue using arrays. Previously, array contained 1, 7, 5, 2. Front was 0 and rear was 3. So if user want to enqueue 6, we know that enqueue or insertion will be done at the rear end. So 6 has been inserted after 2, and now rear index will point to 4. Likewise, if user want to enqueue 8, 8 will be inserted after 6 and rear will point toward 5 index. Now if user want to dequeue an element, then dequeue will be done from front. So 1 will be removed from the queue and front will be pointed to the next element, that is 7. Notice that upon removal, we are not shifting all the element to the left side because that will be expensive. So front will become 1 and rear will remain same. After another dequeue function, 7 will be removed from queue. Now front will point towards second index and rear will be the same. After insertion of two elements 9 and 12, queue will become full now. Although there are two spaces left at the start of the queue, if user want to enqueue 21, he cannot. Why? Because queue is full. There is a problem. We have implemented insert and removal operation running in constant time, but we have created a new problem. We cannot insert new element although there are two places available at the start of the array. So the solution to this problem is to allow the queue to wrap around. It's like a circular queue. And we also need to ensure two problems, underflow problem and overflow problem. Underflow problem before dequeuing operation and overflow problem at the time of enqueue operation. So how can we wrap around? The answer is to use circular queue. The number of locations in this example are 8, starting from 0 to 7 index. The index number are written outside the circle incremented in the clockwise direction. So where we're going to insert 21, we will insert after the index 7. That will be 0. If user want to insert 21, 21 will be added after 7 index, that is 0. We have to maintain 4 variable, front, rear, size and total number of element. Total number of elements are 7, size is 8. We can insert total 8 element in this queue. Front will remain same and rear will become 0. If you notice that the rear index has decreased instead of increasing. So how we are going to implement the enqueue function of this type of array? Let's see the code of enqueue function. In line 1, 1 is added in rear and the mode operator is applied with the size variable. We know that in this example the size of the queue is 8. So this formula will ensure the value of the rear will always be from 0 to 7, increase or decrease. The resultant is assigned to the rear variable. In line 2, the value that user want to insert, that is 21 in this example, is inserted at the rear position of the array and number of element is increased. Before number of element was 6, now it will become 7. To get better understanding, let's solve an example from the start. The default value of front and rear is -1, size of this array is 8 and number of element is 0. So line 1 of the previous code is rear is equal to rear plus 1 mod size. Rear is -1, -1 plus 1 is equivalent to 0 and 0 mod 8 is 0. So the value the user want to insert is 1. 1 will be inserted at index 0. The next two lines of the code are straightforward. The value of the rear is 0, so the element will be added at 0 location. Array of 0 is equal to 1. 1 is the element that user want to add, and number of element will be increased from 0 to 1 because there is only one element in the array. Here you need to add a check in this code, is in this enqueue function. If you are inserting the first value in the queue, then that value will become the front and the rear of the queue. So here with rear, front is also changed. Front will point toward first element, that is 1, and index is 0. If user want to enqueue 7, the value of the rear was 0. 0 plus 1 is equal to 1 and 1 mod 8 is equal to 1. So the 7 will be inserted at index 1 and the number of element is increased from 1 to 2. If user want to enqueue 5, the value of the rear is 1. 1 plus 1 is equal to 2. 2 mod 8 is equal to 2. So 5 will be inserted at index 2. Likewise, you can insert element. So what will happen if we reach the end of the array, like in this scenario, the 12 is at the 7 index and the next value should be inserted at the 0 index because this is a circular queue, and user want to enqueue 21. Will this function or formula will work or not? Let's see that. The value of the rear is 7. 7 plus 1 is equal to 8 and 8 modulus 8. 8 mod size, the size of the array is 8. 8 mod 8 is equal to 0. So the next value is going to be inserted at the 0 index. That's how circular queue work. It circulates from 0 to 7. After inserting 21, queue has now 7 element and the total size of this queue is 8. If user try to insert another element, that is 7, 7 will be inserted at index 1 because the value of the rear was 0. 0 plus 1 is equal to 1 and 1 mod size 8 is equal to 1. So 7 will be inserted at index 1. Now queue has become full, or we can say that array become full. It is important to understand that queue does not have such characteristics to become full. It is its implementation using array that has become full. To resolve this problem, we can use linked list to implement queue. But while working with array, we will write the method is full to determine whether your queue is full or not. We have already handled overflow and underflow problem when we were implementing stack. These are the two functions, is full and is empty. Is full, if number of element is equivalent to size, then your queue is full. And if number of element is equal to 0, that means your queue is empty. It's up to you. You can use int and return 1 and 0, and you can even use boolean or bool to return true and false to ensure this check. Now let's see the code of dequeue function. If you understand the enqueue function, it will be much simpler. In the first line, we take out an element from the array at front index position and store it in a variable x because we need to dequeue an element from front and we need to return that value to the user. In the second line, front is incremented by 1, but as the array is circular, the index is looped from 0 to 7. That is why the mode is being used. In the third line, number of element is reduced by 1. Finally, the saved array element is returned to the user. Now let's see the uses of queue. The most common example is I/O buffers, scheduling queues in a multi-user computer system. Example, a printer or a printer queue. When files are submitted to a printer, they are placed in the printer queue, and the printer software execute an algorithm something like this. We know that queue is first come first served. So when you submit a file to a printer, it printed out in first come first served manner. So this is an infinite loop. If your queue is empty, printer go to sleep. If not, it remove the front element from the queue and print a file. Another most common example of queue is in CPU scheduling. Processor use multiple queues. For example, resident queue when jobs are waiting on disk for the memory, or ready queue when a job only needs CPU to run and they wait in the ready queue. Suspend queue when a job is waiting for IO transfer or to be reassigned the CPU, that job will be maintained in the suspend queue. Another variation of queue is priority queue. In priority queue, queues in which items are ordered by priority rather than temporary. Any queue implementation then can be taken and modified to acquire a priority queue. All the functions or method of the queue will remain same. The only needed modification is in the enqueue method. Instead of unconditionally adding to the back, the queue must be scanned for the correct insertion point according to item priority. Now let's see the differences between queue versus stack. Stack are a LIFO container. That means that it stores data in the reverse order received, while queues are FIFO, store data in the order they received. Stack then suggests application where some sort of reversal or unwinding is desired, while queue suggests application where service is to be rendered relative to the order received. Stack and queue can be used in conjunction to compare different ordering of the same data.